Welcome to this new tutorial. Here we will discuss about a new question. How do you ensure thread safety in multi-threaded Java application? So thread safety insurance in multi-threaded environment is very crucial. It is crucial to avoid issues like data inconsistency, race conditions, and deadlocks. Here are some common techniques and best practices for achieving thread safety in Java. First one is synchronized methods and blocks. Synchronized methods. You can declare methods as synchronized to ensure that only one thread can execute the method at a time. Synchronized blocks. For more granular control, you can use synchronized blocks to only synchronize part of the method locking on the specific object. Volatile variables. Use the volatile keyword to ensure that variable's value is directly read from and write to main memory. This avoid this avoids checking caching of variables in various in variable caching. This avoids caching of variables in individual threads and ensures visibility across threads. When to use? Use volatile for flags or a state variable that need to be accessed by multiple threads and you want to ensure the changes are visible to all threads. Locks, reintent locks. Java provides explicit locks through the java.util.concurrent locks package. Reintent locks, reintent lock provides more flexible lock management than synchronized blocks or methods, such as time locking and the ability to interrupt threads trying to acquire a lock. Here is one example. We have declared reentrant lock, and in the method, we are writing lock.lock, lock.unlock. This can be used. This is useful when you need more advanced locking mechanism like lock timeouts, interruptible locks, or when you need to lock multiple objects. Atomic variable. Use atomic classes from java.util.concurrent atomic package such as atomic integer, atomic long, atomic boolean, and atomic reference. These classes provide thread safe methods for performing operations on variables without needing explicit synchronization. Read write locks. Reintent read write locks allows uh, multiple threads to read a shared resource concurrently, but only one thread can write to it at a time. This is useful when there are many readers and few writers. Thread safe collections. Java provides several thread safe collections in the java.util package, java.util.concurrent package, such as copy on write array list, concurrent hash map, and blocking queue. These collections are designed to handle concurrency internally and prevent issues like race conditions. Executor service. Instead of manually managing threads, using use the executor service to manage a pool of threads for executing tasks. It provides built-in thread pooling, task scheduling, and thread management. We can use executor service for managing concurrent tasks in a clean, efficient manner without manually creating and managing threads. Immutability. Another effective strategy for ensuring thread safety is to make objects immutable. Immutable objects cannot be modified after they are created, thus ensuring that their state is consistent and thread safe. Thread local variable. The thread local class in Java provides thread local variables that are isolated to individual threads. Each thread has its own copy of the variable, ensuring no thread interference. When to use? Use thread local when you want to store data that is specific to current thread, avoiding the need for synchronization. And the last one, avoiding deadlocks. Deadlocks can occur when two or more threads wait indefinitely for each other to release resources. To avoid deadlocks, always acquire locks in a consistent order. Use try-lock mechanism with timeouts, like reintrant try-lock, limit the number of locks held at any one time. Use the deadlock detection strategy. When to use? Be mindful with resources each thread holds and follow best practices for avoiding deadlocks when using multiple locks. In summary, what we can say: to ensure thread safety in Java, use synchronized methods or blocks to control access to shared resources. Use volatile for variables that need to be accessed across threads. Utilize reentrant lock for more complex synchronization scenarios. Use atomic variables for simple operations on shared variable. Opt for thread safe collections from java.util.concurrent. Use executor service for task management and pooling. Consider immutability for objects that do not need to change. Be cautious for deadlocks and thread contention. With this, we came to the end of this tutorial. Thank you.